Welcome to Master Concepts in Chemistry. In this video, we'll learn how to calculate the number of moles and number of atoms in a sample of an element. So let's look at the question. The question says, how many atoms of calcium are there in 20.0 grams of calcium? So to start, we are asked to figure out the number of atoms of calcium in 20 grams of calcium. So the units involved here are atoms and grams, or particles and grams. So to do that, we have to recall our relationship. Remember the relationship between mass, mole, and particles? So we need to recall that. So I'm going to write that here. So we have mass in grams is connected to 1 mole, and 1 mole is connected to particles. Okay, so to go from mass in grams to 1 mole, we have to use an inverse of the molar mass. So molar mass in inverse. Okay, so we flip it. So I'll just say molar mass here. But here we'll have 1 mole on top over grams, because we are going from mass to moles. Okay, and to go from moles to particles, we need Avogadro's number per mole. So 6.02 times 10 to the power 23 particles per 1 mole. Okay. So to go in reverse, we need the flip of Avogadro's number, which of course is 1 mole of Avogadro's number. And if we want to go from moles to mass, we need the flip of this, which is of course grams per mole. But our question says, how many atoms of calcium are there in 20 grams of calcium? So we are asked to go from grams to moles and then particles. So to start, we'll draw our table. Okay, we'll draw our table. And then what is given is 20.0 grams. So we'll put 20.0 grams of calcium here. So we just write a small subscript by the gram just to indicate that we are calculating for calcium. Okay, now as you've seen, we have 20 grams here because that's what is given. So what is given, we normally write it on this side. So I want to go from 20 grams to moles first before we go to particles. So that means the next unit we are interested in is the mole. So mole here. Since we don't want grams, grams should be at the bottom. So grams will cross out. Okay, now we need to look for the molar mass, since the molar mass has moles and grams in it. So we have to look for the molar mass of calcium. So if we go to the periodic table, our molar mass of calcium is 40.08 grams per mole. So molar mass of calcium, so molar mass of calcium is molar mass of calcium, write it here. Calcium is 40.08 grams per mole. So you see, so for every 1 mole of calcium, it weighs 40.08 grams. So since our 40.08 gram goes with grams, we'll write the 40.08 here. And mole, 1 mole, 1 goes with mole, so 1 on top. So you see that. So we'll put calcium here just to show we're calculating for calcium. So units on the diagonal will cancel, so grams will cancel grams. So we just have moles left. Okay, so we are now here at this point, moles. But remember, we don't want moles, we want what? Atoms. So the next step is to include our atoms, which is what we want. So we want atoms. Okay, so atoms here, taking the place of particles. So meaning here should be mole. And what are we calculating for? Calcium. Calcium atoms. So write calcium here. Okay. So first, how do we go from moles to atoms? So we have to go through Avogadro's number. Yeah. Per mole. And as you've seen, Avogadro's number goes with what? Particles or atoms per mole. So that means our top number here should be Avogadro's number, 6.02 times 10 to the power 23, and the bottom here should be 1 mole. Okay. Then we close our table. So units on the diagonal will cancel. So now we just have our atoms of calcium left, which is what we want. So now we'll proceed to multiply and then divide. So as you've seen, the horizontal line just means division. So this is the division line. the horizontal line, and the vertical lines just means multiplication. So this multiplication, this multiplication. So basically I'll multiply 20.0 by 1 by 6.02 times 10 to the power 23 divided by 40.08. Anything divided by 1 is still the same thing. So once we do that, our answer should come out as 3.00 times 10 to the power 23 atoms of calcium. Okay, atoms of calcium. Now here I'm putting the answer to trace significant figures because we've seen this has trace significant figures, this has trace significant figures. But again, yeah, I just don't want to stress significant figures here. Understanding the process is key at this point. Okay, so that is that. Now we can translate this same calculation in the form of a table by replacing the horizontal lines with the division bar and also the vertical lines multiplication. So we can rewrite this expression as follows. So we can rewrite that as 20.0 grams times 1 mole divided by 40.08 grams, then times 6.02 times 10 to the power 23 atoms over 1 mole. Okay. Yeah, and remember you can add a calcium if you want. So this calcium. So as you can see, grams will cancel grams, moles will cancel moles. So it's all the same setup as we have in the table. Okay, but usually the table makes it a lot easier for you to cancel out the units on the diagonal. So if you are working such a problem and then you notice that the units on the diagonal don't cancel, then that means that there might be something with your setup. So it's a cue to help you track where your error is. Okay, so that is that. So this is how to calculate the number of atoms in a sample of an element. So as you've seen, to find the molar mass of our element, we just read it from the periodic table. That's just all with it. Read from the periodic table. In some questions, you don't always have an element. You have, let's say, a compound. Okay, and we'll look at examples of that sort. Okay, so thanks for watching.